Sometimes it's really easy to overthink something. I had about 10 calls with the trucking dispatcher to discuss how we were going to load these crates because, you see, a household moving truck does not have a liftgate, a forklift, or pallet jack. And, these are big crated machine tools, so it wasn't clear to me how they were going to load them in the truck. And we talked about a million different options and different ways around it. Sometimes they hire tow trucks when they need to load things like pianos and safes. And then, as is often the case, the answer is 3 strong guys who know their business showed up and loaded both these crates in 8 seconds. Hello Internet, my name is Quinn and this used to be Blondihacks. As you can see, I'm sitting on pallets and next to some boxes, and that's because it is moving time. Yes, after 10 years in this shop and 4 years of YouTube in here, it's time for me to move. And this is not a small move. I am moving about 1,500 miles and over an international border. So a move like this is not for the faint of heart. I've got a lot of work to do, but I'm going to do my best to bring you along the way so that you can see what the process of moving a hobby shop looks like. So, let's go. I'm packing in reverse order of how likely or commonly the things are used. So after I called the last project in the shop, I could safely pack up all the materials here. All of the hand tools, for example, get packed last because they're going to be needed as part of the packing job. For the long bar stock, I'm bundling it together in decent sized bundles and just taping it up. It would be ideal if I still had a bunch of those cardboard tubes like McMaster ships this stuff in, but I don't, so this will work. Once again, this is just scrap metal. The thinner, delicate stock is packed in bundles with the heavier stuff, so I've got like 540 threaded rod in there with a bunch of heavy brass bar stock, so that's not going to get bent or anything like that. For especially slippery stock like this precision ground bar stock, the center can slide out. This also happens if the bundles get too big, so for these I just tape up the ends as well to keep the center pieces in place there. Onto the tooling cabinets next. These are on wheels and ostensibly can be rolled into the truck, but fully loaded, these things are very, very heavy. So drawers like this that are full of heavy tooling, I'm going to unload. For tooling, things like angle plates and so on, I'm using the same process throughout, which is to oil everything up, make sure that any standing humidity isn't going to cause flash rust on everything, and then I'm protecting the precision surfaces with extra cardboard there. You can see I've also got a board in the bottom of the box. That helps strengthen the box and protects the stuff at the bottom from getting set down on anything sharp, things like that. A lot of my tooling already has its own foam-lined wooden box like this vise here, so for that I'm going to leave it in that box. It's safer than anything I could do, but I am going to tie it up so that the box can't pop open if the box gets jostled. For this, I'm using a technique that, I don't know, I guess they don't teach kids anymore, which is package tying. This is how we used to mail things. Do they teach kids how to do this anymore? I feel like they don't. Anyway, it's a good skill. So if you're under 40 and you're watching this, learn how to cross-tie a package with string. I'll mention here that the movers did actually tell me that I can leave everything in the drawers in all of these cabinets, but I don't think they appreciate how heavy these things are when they're fully loaded, so I'm unloading almost all the drawers. The most important thing when packing tooling like this is to make sure everything in the box is immobilized. This is advice I got from the great Tom Lipton during his big shop move. Movement is what kills things, so make sure that everything in there is packed tightly together. And you also need to keep the boxes from getting too heavy. The cardinal rule of moving is you pack heavy things in small boxes and light things in large boxes. If the box is clearly going to get too heavy, like this one might, then pack the top half of it with light things like shop towels or whatever. For a drawer like this one, where it's already packed full in factory packaging that's better and safer than anything I could do, I'm just going to leave this one as is. Next up in here are a whole lot of hardware drawers. I have a million of these little bins full of all kinds of goodies. These are not heavy, so they can stay in the drawers, but of course I don't want this to be utter chaos when I arrive and have to sort everything out. So what I'm doing here is I'm emptying each little bin into a little Ziploc bag, and then I put the Ziploc bag back in the bin. And for some of these bundles, I'm also taping them up so that the bags kind of stay in a little ball. This way, if things get dislodged in here, at least everything's still grouped together and I'll be able to put it back in its respective bin. Over here in the lathe tooling drawer, I'm using a lot of what I call the dirty snowball method, which is to wrap each of these odd-shaped components in bubble wrap and then kind of ball it up with some tape and then pack them tightly together in the box. This way there's nothing metal touching anything else metal, nothing can scratch, but the whole assemblage there can take weight that's pushed down on top of it. I'm always thinking about what's going to happen when a heavy box is put on top of this box. You want to make sure that that weight can go down through the box without damaging anything in the box. More delicate things like dial indicators and such get packed additionally in a plastic bin, which is then placed inside the box. So the plastic bin there is taking the weight of the stuff above it. And I'm also using a lot of butcher paper for things that are tougher and or that I just don't care as much about. When moving a hobby machine shop, you also need to be aware of what chemicals and compressed gases you have, because those are often restricted. A household moving truck is not hazardous materials rated, so they're not going to be able to carry a lot of stuff that you might have. A classic example are oxygen and acetylene tanks. In my case, of course, there's no way these can go in any kind of enclosed transport vehicle. So these went back to the Welding Gas store, and I will buy new ones when I get to my destination. Some things like the surface plate, I still have the original shipping crates for them, so I just put them in those crates because, again, they're safer than anything I can build, and I just ratchet strap that together to keep it nice and safe. Alright, let's get to probably the reason you clicked on this video, which is the machine tools. These need to be measured for crates, of course. I've got some secondhand pallets that I got off the internet, and I've got some lumber here, and let's build some crates for these machine tools. The plywood that I'm using here is 5mm underlay. It's handy because it comes in these small sheets that are easier to manipulate in my small space here. I don't have a lot of carpentry tools, but I will be making good use of my fine Turbo 1 shop vac here. Makes great small-scale dust collection for a task like this. I'm going to be doing everything with the miter saw and my little skill saw. This miter saw, #not-sponsored, has the blade shadow feature, which I absolutely love. It's so much better than those lasers that some of them have, which you can only see in very specific lighting conditions. Super annoying. And now, a quick aside for everyone's favorite fact about tape measures. Do you know why the little tab at the end is loose? It's so that it pulls in one way and pushes in the other, and thus compensates for the thickness of that little tab. And I know everyone loves to tell you that because everyone thinks that nobody knows this. But now you know it too, just in case. I'm using a very standard crate construction technique here, just 1x2s nailed to the outside edges of the plywood, and then these panels that I'm making will be assembled into the crate when we're done. I'm using T-shaped brad nails here to attach the 1x2. You could also use some glue here, I guess, if you wanted, but I want to be able to reuse this wood later, so I want to be able to pull it apart. Now I started by nailing these from above just to see how well this would work because it's easy, but I didn't like how that was working. It was clear this wasn't going to be a very good grip there. So I decided really these need to be nailed from the other side because then the head of the brad nail is in the plywood and then the shank of the brad nail is in the thicker wood where it's got lots of friction. And this made a much, much better joint. So this should hold sufficiently, I think. These panels, mind you, are not structural. We're not shipping these crates on an ocean liner where it's going to have things stacked on top of it. These are just sort of shields to protect the machine tools that are sitting on top of the pallet. There's different grades of crates, if you will, and this is a very light-duty grade. Thanks to these small sheets of underlay ply, I didn't have to make a lot of cuts, but the ones that I did do with my skill saw. I set the depth of the blade there the way my dad taught me, which is that the bottom tooth should be halfway through the bottom of the material, which minimizes tear out and makes a nice clean cut. I had a lot of these panels to make for both machine tools, but I got quicker and quicker at it, as one does. I developed a system of clamps where I could clamp up multiple pieces at a time and flip it over, do all the nailing, flip it back, measure the next pieces, and so on. So this all went pretty fast once I got into a rhythm here. At the end I had some extra lengths of the sticks, so I used it to add extra bracing to some of the larger panels. I either have to use it or pack it, so I'd rather use it. Now to prepare the lathe for shipping and storage, I'm cleaning the ways and covering everything with a very thick layer of whey oil, much thicker than you might use just for normal use. This is very, very thick here. And I'm also sliding the tailstock and the carriage all the way down to the far end because that's going to help balance the weight. And I'm locking all the slides to make sure nothing's going to move. This is an overland move, and it's only a couple of weeks in length. If I was moving overseas, or if the stuff was going to be in storage for a long time, you'd probably want to look at using grease instead of oil, something that's going to stay on these surfaces longer, especially if there's going to be any kind of saltwater environment involved, or if you don't know how long the stuff's going to be stored, or if you don't know the humidity conditions where it's going to be stored, then you might want to give thought to grease. In my case, it's a straightforward overland move, long distance but relatively short in duration, and I know exactly where the stuff is going to be the whole time, so a heavy oil coating here should do the job. Now let's talk safe lifting. These hobby machines aren't really that heavy. 3 or 4 strong people could probably lift them, but that doesn't mean we shouldn't practice good safety. So these are lifting slings. I've got some large ones here and some small ones. These are what you use for proper lifting because they can handle shock loads and abrasion. Do not use ratchet straps. These things are too thin. The ratcheting mechanisms are not designed for suspended loads. These are for attaching a kayak to your Subaru, not for lifting something heavy. Next, you need some kind of rings or shackles. These are D-rings, which are probably the best. They're certainly the safest, and they come with the highest load ratings. There's also these things. These are spring-loaded. These aren't rated quite as high, but they're okay for small hobby machines like these probably. And then back on the farm, we used to use chain repair quick links for everything, and I don't know, none of us ever died lifting heavy stuff with these, so those are probably fine too. The point is you don't want to be tying knots in straps, and you don't want to be running straps through hooks. You want rings and shackles to be doing all of the interfacing between hooks and straps. The number one safety rule for lifting anything is never put any part of your body under the load. The only thing between you and the ambulance is a 15-cent O-ring inside that hydraulic cylinder. Next, always have a lifting plan. Think about where the machine is going to go, where the crane is going to go, how you're going to move it, how things are going to swing, when you're going to make your turns, and so on. With the machine hanging in the air in the middle of the floor is not the time you want to find out you don't have room to swing the crane around to lower it back down again or other such shenanigans. You want to minimize the amount of time that the machine is hanging in the air because that's the danger state. Obviously, we have to start by unbolting the machine from the bench. This machine has 1 bolt under the tailstock and 2 bolts under the headstock. As for how to lift the machine, first and foremost, follow the instructions in your manual because the manual knows what the weight distribution of the machine is and you probably don't. Generally for a lathe though, you're going to hang the straps under the bed, make sure you go behind the lead screw, make sure there's nothing between the casting and the strap because that of course will be destroyed. And then I'm using rings here to attach the ends there. And I want to get those straps as far apart as I can there on the bed for better stability. Now it's time to assemble the crane. I'm using a basic little shop crane, also called an engine hoist or an engine picker. This thing has pulled many a lump out of many a poorly considered automotive project, and it will certainly do the job for these little machine tools. These little shop cranes are awesome purchases. They don't take up a lot of space, and they sure make life easier in a machine shop. Important safety note when using 2 straps like this. When there's nothing to catch the straps to hold them in position, they're going to want to pull together like this, and then the machine can tilt, and worst case, even slide down those straps. And that's a nightmare scenario, so you really need some kind of spreader to keep those straps in position. Something as simple as a board will work here for something this light. There isn't going to be a whole lot of force on that spreader. Just something that will make sure that those straps stay apart. I'll put some tension on here, and you can see that that's going to work just fine. I'll straighten that out a little bit. And we can start doing some test lifting here and see how this is going to go. One last check to make sure everything is clear, all the bolts are out, no electrical connected, nothing like that. And now we can start lifting. The first thing I'm checking for is where is my weight balance. Right away I can see it's very heavy on the headstock end, even with all the carriage and everything at the other end. So I'm not happy with that. I'm going to gently set it back down and make some changes here. The straps can't move any further towards the headstock because the chuck is in the way, unfortunately. I was hoping to leave that chuck in place because it'll protect the spindle nose, but I need to balance the weight better, so I removed the chuck and I'll put some protection here on the spindle nose, a little bit of cardboard just to keep anything from banging into it. And then that removes the weight of the chuck and lets me get the straps a little further on that direction. And now the weight balance is much better. That's just about level there, so I'm happy with that. I'm lifting this just high enough to get the chip tray out, and then I will set it back down because I want to use the chip tray as a drilling template for the pallet. I'm setting that back down because you don't want to ever leave the load suspended any longer than necessary. Over on the pallet, I want to figure out where I want the lathe to sit, make sure I've got room at both ends, and make sure that the mounting bolts there are aligned with one of the boards on the pallet, because of course the machine's going to be bolted through. Remember what I said about having a lifting plan? Well, I realized the lathe is going to need to go the other way to avoid an extra turn with the crane, so my pallet has one extra speed hole in it. Okay, lift it back up, and now carefully pull it clear of the bench. As soon as it's clear, then I gently lower it back down for the move over to the pallet. The lower a load is, the safer it is, so you always want to do everything as low as possible. And in fact, in this case, because it's wide, I can actually kind of set it on the feet of the crane there a little bit, which makes it easier to move around safely. It's not going to be swinging. It's crucial when moving the load to make sure that it can't swing or spin. So taking some of the weight with the legs of the crane is a very easy way to do that. The big downside to using an engine hoist for this type of thing is that the feet are always in the way when it comes time to set the thing down. There's different strategies for working around it. In the case of the lathe here, my strategy is to slide the drip tray over to the edge of the pallet, and then I'm using some blocks of wood and some clamps to kind of push the lathe just past the ends of the feet on the hoist there. And then once it's on the drip tray, it's relatively easy to slide it on the pallet. A bit longer strap there helps too if you can, because it gives you a little more leeway to push the load outwards a little bit. And then once it's on the pallet, then I move the crane around to the other side and I apply a little bit of lifting force from the back. Now it's at an angle, so I'm not going to be able to lift it from back there without tipping it over, but I'm just using the crane to take some of the weight off of it so that I can slide it over into position and then get the bolt holes lined up. Getting the bolt holes aligned is by far the worst part of this. One thing I figured out later is draw the outline of the chip tray before you set the lathe down so that you know where the chip tray will be when it's aligned with the holes in the pallet. Yes. But let's just say I was very glad when I got that first bolt in. I'm using large washers below there against the wood, and I'm also using nylock nuts just to make sure nothing comes loose, although that's probably overkill. You might be wondering why I put the lathe off-center on the pallet, and that's because the pallet is larger than necessary, so I'm going to use the extra space here to put some of my other smaller things in there, like the D-bit grinder. I don't really have a good way to move this thing either, so I might as well put it in here. This thing weighs about 100 pounds, so it's actually a good weight to put in this corner back here, which will offset the weight of the headstock on the lathe pretty nicely, I think. There isn't a great way to bolt this thing down. There's no holes through the casting except for one there where the accessory post goes. So for the other end, I just bolted the rings of a ratchet strap down and just ratcheted that down nice and tight. That should be plenty secure. But just for some extra insurance, I also screwed some blocks down around the outside of it there just to make sure it doesn't slide. And now I can start putting the sides of the crate up. You'll note that the plywood is on the outside, which is the opposite of how you see a lot of DIYers make crates. I think that's because people get their impressions of crates from cartoons and video games, but you want the plywood on the outside so that if something hits that plywood, you're not relying on screws or nails to keep the plywood from collapsing inwards. The sticks are there to hold it in place. The sides of the crate are held in place with tape just to get everything square and aligned, and then the corner sticks get screwed to each other all the way down all the sides. Now for holding the structure there to the base of the pallet, I drilled angled pilot holes and kind of toe screwed it. I don't know if that's a word, but kind of toe screwed it into the pallet. There's probably a better way to do this, but this seemed to work okay. I still had some extra space inside, so I just screwed a cardboard box down to the empty space there and used that for some of the smaller loose bits that will go in there as well. I didn't want to overload these crates too much because they start to get too heavy to move. One last look, little lathe buddy. We will see you in a few weeks. The top gets screwed down, and, well, I hope that this thing will be safe and sound until we see it at the other end. Over to the mill now. It's very much the same. I start with a heavy oiling on everything. The mill is a lot more of a hassle because it's much more difficult to get to all the surfaces, and there's a lot more surfaces to do than the lathe, but do it we must. Got to protect everything from flash rust and moisture. Don't forget the table, of course, and the vise itself. You might also consider removing the vise, but this vise isn't very heavy and it's not going to add a lot of weight or imbalance to the lift, so I'm inclined to leave it in place. And there's oil underneath it there, so it's already protecting the table. Now the most important thing with lifting the mill is to lower the head down as far as it will go and to lock all the slides. For the DRO, I'm going to leave it in place. I'm just going to fold it out of the way. This is how it was shipped to me from the manufacturer, so I know that it's safe to do that. Now, the lifting strap for the mill, again, usually they go under the head like this, but check your manual because they are all a little different. The most important thing is make sure there's nothing under that strap. No electrical, no kip handles, no bracketry, nothing like that. Anything between that strap and the cast iron is likely to be destroyed. So watch that electrical box especially, and those plastic handles there. One trick with the mill is that you need a lot more space above it for the crane than you do for the lathe. In my case, I have it installed underneath shelving. So what I did when I first got this mill was I put a hinge on that shelf. That's how I installed this mill, and that's how I'm going to remove it. Once again, the bolts come out of there, of course. I'm prepping the pallet again using the chip tray. You might have noticed I don't actually use this chip tray on my mill, but I did still have it, so it made a handy drilling template. In my case, this lift is right at the height limit of this hoist, so I'm kind of lucky that I can do it, although I could shorten those straps a little bit if I needed to, but luckily I can get away with this. And once again, up we go. The mill does get pretty swingy, unlike the lathe, because it's got a single lifting point there, so it really wants to spin around. It's a little bit of a job to get it pulled out of there without getting things swinging and spinning, which is, again, the dangerous thing you want to avoid. Once again, once I'm clear of the bench, I lower it down and do everything as low as possible because low is safe. To deal with the feet on the crane this time, I took a different approach that worked quite well. I blocked up the pallet so that I could slide the crane underneath it. In the case of the mill, I really needed to set it right down in the middle of the pallet. I wasn't able to place it on the edge like I could with the lathe. You can see the pallet drooping there a little bit because it's not really designed to be held up by the corners like that, but that's okay. The crane is still taking most of the weight, and now I can get the bolt holes aligned, bolt everything down. Now I can lift the mill and the pallet back up with the crane, pull my blocks out, and then set this down. As it comes down, it's going to kind of tilt backwards as the back of the pallet is not under the feet of the crane, and that's okay. Then using a floor jack to take some of the weight on the front there, I was able to wiggle the crane out and then lower the pallet down to the floor. I got away with that because, again, these machines aren't really that heavy. For something much heavier, I guess you'd have to come up with something better. I don't know. And then the second crate was assembled the same way. For some reason, I made this crate rather taller than it needed to be. Well, there it is. Blondihacks 1.0, all packed up. I'm exhausted. Wake me up when the truck gets here.